hear me? Is this thing off?
Yeah.
Barely. Barely. Okay. Are we good? Sound guys? Or I don't know where the sound is. Where's the sound? Maybe I should use this. Is this better? Do you have the handheld? Yeah. I'll use the handheld. Does that work? That's great. Okay. Great. I have too many labs on anyway, so now I can get rid of one at the break. Hi everybody, good evening. Thank you for coming, and thank you for coming again if you came the last time I spoke in New York. Hopefully there'll be some new material and we'll have resolved some of the things that were mysteries in December. So one quick and substantial probably change in the introduction is that Concept actually turns 20 this year. It turns 20 in August, end of August of this year, which is a little bit nuts. Because that means that I've been working on the same open data project for 20 years, which is one of those things that when you start it as your undergraduate thesis project, you don't think that's going to happen to you. But that's another story. So I already had a little bit of an introduction, but I'll add a few things to that. So I am, I guess, a longtime affiliate with the MIT Media Lab, where I've studied everything from NLP to, with students have studied everything from NLP to now computational creativity dialogue systems. I do a lot of work with startups. I love startups. So I both advise and teach that at MIT, as well as I'm active in a number of different companies that are startups of different sizes, ranging from Luminoso, which was my first NLP startup, which is now about 80 people in 2010, down to my newest startup, which is delaying. I'll talk about that a little bit, which is 3 people. So big differences. And I'll hope to touch on a lot of that as we go through that. But to start with, I'll talk a little bit about sort of how we got started on this journey. I want you to think back to the late 90s. I want you to think back to the world before Google. Everybody remembers probably the world before Google in this room, but it was a really long time ago. And remember when we first started searching for things, right? Before Google, there were Hotbot and Yahoo and Lycos, and there were so many different search engines, and we used to get into arguments about which search engine was better than which. And we searched in a different way then too, right? We would go to search engines and we would type in things like, I want a pizza, and my cat is sick, and things that are much more conversational. The way we search now is very algorithmic. We think about the way we search. We really think about the keywords that we use. That's not what was going on there. And so there was this big battle going on between all the different search engines and all the universities. They were coming to the universities, or they were coming out of the universities in some cases. We'll get to that. And thinking a little bit about how can we make search smarter. So while this was going on, I was at the MIT Media Lab as a student, and I was working in Marvin Minsky's Society of Mind group. And Marvin was, of course, thinking about search, because at the time everyone was thinking about search. And I guess his idea was to take the way people searched and try to figure out what we would now think of as the intent of the search. What was somebody thinking? What was their goal when they were making a search? Why did they type "my cat is sick" into the search box? And if we can understand that on a deep level, then we'll be able to understand how to give them the result that they need. So we started a project at that time, and this is 1999, to do what we called harness the power of bored people on the internet, to start collecting data from them that we could use to make the computer smarter. We figured SETI had actually just started. Where this actually came from is SETI had just started maybe 3 or 4 months prior. And I was much younger, and I thought this was awesome. I loved, going out in my backyard and looking at the stars, and I thought it was a really great idea to try to figure out if something was out there by putting all of our computers together. So how about we put our heads together and think about AI, right? And so that's kind of where that came from, as we were working that off. And so we had a little box. There was this new search engine, and I was into search at the time, so I was very into this. Out of Stanford, they had this great minimalist design, and having lived through web design in the 90s, I was very excited about that, because it was not like a flashing background or anything like that. It was just a white page with a button. So we actually had a white page with a button, because we pretty much ripped it off, with a button that said teach the computer. And so people would type in things like, a cat is a pet, and we like our pets to be happy, into the search box. And except it wasn't a search box, it was a teach the computer box, and hit the button. And so we started getting all this data, and people would do this when they were bored in class. Often when I give talks, someone in the room actually did this in the early 2000s or 90s, or in its later instantiations, which we'll talk about. And they would teach the computer different things. In the meantime, on the West Coast, in the other side of the country, at a very different university, they were thinking about something we weren't thinking about, which was trust and information provenance. And they were thinking, hey, there's a lot of stuff on the web, and things that more things link to are more likely to be where your answer is, as opposed to, people's goals. And so that happened, and we did not build intent-based search. Instead, we built a big model of how people think about the world. So we took the data from there, and over the years, we teamed up with every talk I gave, every academic talk I gave, and then when I started having students, every academic talk they gave, we ended with, hey, if you want to help with this, come over and find us. A person would call an n-gram, so 1 or 2 words strung together, or it could be a single word, or it could be a very long phrase. And they're connected together with different kinds of relationships. And we initially looked at, to be honest, we looked at the things people entered into the little search box in 1999 and said, hey, what types of relations do they have? Eventually we had a prompt that showed you a statement someone else had entered. So people started using priming to enter the same things, same format of things that someone else did. So these natural patterns kind of emerged in the data, and that's mostly where the relation set came from. When I was finishing up PhD in basically computational semantics, I started trying to put more structure on there. But largely it's just, hey, this is the way people actually decided to enter data into the computer. So we have about 24 different relation types. And so it's this giant knowledge graph. And it's multilingual. We, as I said, we work together. We worked with folks in the Netherlands and Brazil, in Japan. Japan was crowdsourcing longer than English. Japan only stopped crowdsourcing last year. And use that to build this really big knowledge graph in many different languages. But as I said, search moved on without us, right? So instead of figuring out what people's intent was when you searched, people started searching different. People didn't say, my cat is sick anymore. They said, what is a veterinarian in New York City? And that changed the way search worked and the way we communicated with computers. And so basically the evolution of the user experience for search was this co-evolution of technology and users, right? So users evolved the way they interacted with the machine, and the machine evolved the way it expected, to a point where we have a special language that we use to talk to search engines, which these days is usually Google. We've seen that pattern happen again and again in the way people communicate with technology. We saw it happen again with Siri. What's really interesting here is when Siri first came out, people would pick up their phones and they would say things like, they would talk to Siri like you would talk to another person, right? And that didn't work very well, except for outside of the things that Apple programmed in manually or the basic intent tracks that came into Siri. So in times we sort of learned what Siri and Alexa were good for, right? We started treating Alexa less as an intelligent agent and more as a smart speaker that plays our podcasts and turns the lights on and drives Spotify, at least in my house. That's mostly what Alexa does. And it's the same co-evolution again and again and again. We learn to talk to computers the way that technology enables us to talk to the computer, not the way that we want to. So we kept collecting data. We collected data for 20 years. We're still collecting data. And what ended up happening was this wasn't used for search as much anymore. It was integrated into different kinds of systems. We had a knowledge graph out there for years that people used. Lots of people used it in many, many papers. And it sort of focused on the idea of building things that people knew and computers didn't into systems. This field is called common sense, which is a really interesting name. I didn't come up with it, but it makes it really hard to explain to people what you do. I study common sense. You get a lot of snarky comments. And basically what it does is it helps the computer fill in the gaps. It finds the things that we tend not to say very often. You know, if we're telling a story, we never say if we drop something that fell down and hit the floor. We tend to say things that are a little bit more exciting or different. We only talk about things that are notable. We never talk about the things that aren't notable. So our training data sets tend to be biased towards things that can be a little bit middling or extraordinary and not the very basic everyday world. So that's great, but that means we have to see things a lot of times before we learn them. And as many people have noted, and that sometimes very humorously, this is not really how people do it, and this is not how we're going to be able to do it in the future. So how do we do it? And this is where common sense comes in. So if I put up a picture of a giraffe here, and I've talked about common sense in many, many rooms in this point, every single person in this room has a good idea of what would happen if a giraffe suddenly appeared in this room. Would it be very happy with the height of the ceiling? Would it be able to find food to eat? What would happen, right? And so we all have a little guess, and at this point we all have a little image going on in our head, and that image is probably pretty similar. And there's two sides that sort of illustrates the two sides to common sense. One side of it is the facts about the world that we all know, like what is a giraffe, how tall is a giraffe, giraffes have long necks. And the flip side of that is the things about the world and the attributes about the world that we can intuit very quickly, and most people intuit the same attributes, right? Things like, oh, a giraffe is going to need a high ceiling, even though we never thought about this before, right, in our entire lives. And the other side of common sense is using it to explain, and what became the most relevant is using it to explain more complicated concepts. So George Lakoff is a linguistic philosopher, and one of the big things he's known for is the idea that we understand complicated concepts by making analogies back to simple concepts. This is one of the reasons that when we teach language models and when we test language models, we always talk about analogy, because analogy has sort of really been tied to the ability to do linguistic reasoning. So if we think about it, let's use data as an example, right? We talk about data like it's water, right? There's a computer, anything that you thought it didn't know that it needed to know. Those were, for the most part, the three categories of things people told it. And I think it took a long time for us to think, wow, that's an interesting data point in itself. Much of the data we ended up collecting, especially in the undirected crowdsourcing phase, was emotional. And one of the reasons for that is because when we communicate with machines, we want to communicate in the way we communicate with each other, emotionally. So these days, I was a very early proponent of using vector-based word representations. So I'm thrilled that this is going on. And for people who don't know a lot about NLP, there is, when you do deep learning on NLP, or something like deep learning, ankle deep learning, whatever you want to call it, you tend to build these things called embeddings, which are representations of different vectors. And a lot of the ways things used to build these embeddings these days are by the distributional semantics, what words are near each other in a sentence. And so that's great, and I've spoken a lot about the different things that happen with that make it not 100% helpful when it comes to common sense, right? It tends to be a black box, and again, we're looking at the wrong kind of distributions, right? If you want to know that a cat is cute and fuzzy, you need to see it a bunch of times. Which honestly, now that I think about it, is probably something you see a bunch of times on the internet, but you don't tend to see things like gravity falls down or not. So the integration of more symbolic systems with deep learning was something that really we had been working on in the lab, and actually we took out into a company called Luminoso and didn't publish, but was published, a better version of it actually was published by Manuel Ferrucci in 2015 called retrofitting. Retrofitting was the idea that you take a knowledge graph and you can figure out how to integrate that knowledge graph into an embedding. And that's that in a second. And for those people who don't know what BERT is, I have a slide for that too. So ConceptNet, so we came out with an embeddings toolkit. It's on GitHub. At the end of this talk, I'll send out links to everybody here with the GitHub, both for doing retrofitting out of Carnegie Mellon, so you can take your wonderful knowledge graph about medical devices and retrofit it onto WordNet too, or you can take WordNet if you really, really like WordNet. It's already in our ConceptNet model. You can add that in. There is GitHub code for that now. If you've heard me speak before, there wasn't. And there's also something called ConceptNet Number Batch, which is ConceptNet's version of a mass-produced embeddings model that's open and easy to use. We combine a lot of stuff together. We also fix glove and retrain it, and then we do all kinds of different things. We put together an ensemble method. We add in ConceptNet, and then we debias a little bit, which is a whole different topic, because debiasing has gotten very complicated in the last couple of